All right, CNT120, we're continuing Chapter 1. So I now have a section on how networks are used. Well, we've shared some of these tidbits, but they're going to give us a little bit more details here, kind of the behind the scenes. So network services, the resources the network makes available to its users. These are things we use that we might not think about. Different applications that are found on networks, if you will. So client-server applications, the client computer is requesting something from the server. And it could be as simple as, I want a web page. I want to be able to load a web page. So the server would be responding with, oh, okay, here's the page you need, and can display on your screen. So we're talking about those applications now that are going on behind the scenes, if you will. As I like to say, these are things that are, without a network, aren't very useful. You know, those kind of things. So with this, we're talking about HTTP. When I want to load a web page, I'm using HTTP. That's a request I ask of the server, and the server responds to me and displays in my browser. Well, this is all part of the TCP/IP protocol suite. It's basically a bucket of protocols, with each protocol having a function that it can do. And as we see here, there's a lot. We'll eventually know these. Do not get overwhelmed by them now. But I'm just showing you this is the OSI model that they'll talk about later this chapter. And here are a whole bunch of examples of those protocols they're talking about. There's HTTP right there. So as I'm doing things on a network, I'm using these protocols to request certain things. And that protocol is written in such a way that do it this way and you'll get this file. Do it this way and you get this file. Do it this way and you get this response. Do it this way, you'll get this action. That is all part of the TCP/IP protocol suite, which is really just a big bucket of protocols that will do specific tasks for you. So some of them are, and these are some of the ones they're going to mention for us. The first one being web services. Yes, if I want to get a web page, my computer asks via HTTP to a server, and the server goes, oh, okay, here's the web page for, you know, Major League Baseball. Here's the web page for Formula One. Here's the web page for NFL football. And that would be the HTTP protocol that is doing that for you. Now, if I want it to be secure, which many websites now are, your HTTP adds security out here on the end, S, through things like SSL or TLS, Secure Socket Layer or the Transport Layer Security. So that web request is now encrypted. And we see that when we load, or I should say, a log into a bank and do banking, or I log into my email. A lot of times I will get that encryption notification. So that, when I'm logging into the regular web page HTTP, but when I log into a website that's giving me that security, that encryption, I'll see HTTPS, or I'll see like a padlock icon. I usually always just pay attention to the S. And anytime I'm logging into banking or things like that, you will definitely see that. And more websites now than not are using that. That way your communications are encrypted and safer from being compromised, if you will. If I'm going to do email, I'm now using two different protocols. One to actually send my email, SMTP, Simple Mail Transfer Protocol. I will use that to send the email to the mail server. My mail server would send it to my friend's mail server, if you will. It'll wait there. And then when they ask for email, they'll be using old school's POP3, modern as IMAP4, but they'll use one of these protocols to pull the email off the server to their computer, their tablet, their phone, their laptop, whatever, so they can view the email and respond to you. So if I'm doing email, I'm using a protocol, SMTP, Simple Mail Transfer Protocol, to send the email, and the receiver is using your POP3 Post Office 3 or IMAP4 to pull that message from the server so they can view it. So again, another client and a server, another client and a server. And here they are. Here's SMTP, POP3, IMAP4 to do your email. If I'm going to load a web page, now I'm a Formula One nerd, so I'm using Formula One as an example here. But if I'm going to load a web page, I remember Formula1.com. I can't remember 13.224.214.8. Most of our brains don't work that way. We remember names easier than we do numbers. So a long time ago, they figured out, well, why don't we just use names for websites, and we'll have a server, DNS, take that name and resolve it into an IP address. So there's DNS servers out there, domain name system, DNS servers out there that will take whatever name you type in and look it up and say, oh, it's actually this IP, and now it can go search the internet for this IP, this server that has this IP, and it could now respond to you. Oh, you want my web page? Here you go. Whoop. Okay, so there's a DNS server out there that's going to take the name I type in, Formula1.com, and resolve it into an IP address, and then I have that IP, and I can go ask that IP for, please give me your web page. That's what DNS is. There's servers responding to that. So I think here's an example here. If I type in, Amazon.com, the server responds with the IP, and now I can go ask that an individual server, hey, give me your web page, and it can give me its web page. Okay, so there's actually the DNS process kind of boiled down, but there is another client-server process. Database. Databases is another, as I order things, it's usually referencing a database of like, yes, I do have that in stock. Or I'm using databases as I'm putting my name in. Yes, this guy is an employee here, or yes, this is his record. This is their grades. This is their health record, etc. There's a database running to maintain all of that, and your database management system is usually using a programming language called SQL, Structured Query Language, SQL. And you might run into that SQL Server or Open MySQL Server, that sort of thing. That's your database. FTP, this is kind of older school. When I first started maintaining websites, and even my wife maintaining her website for her business, we would FTP files up to the web server. FTP was a way to transfer a file from my computer up to the web server, and it would update the web page for her. So FTP was a way of transferring files from place to place. And old school FTP was not secure, which is why they mentioned, and actually here's an FTP application. This I think is FileZilla. I think this is one we were using for my wife for a long time. FileZilla allows you to transfer a file from here to another device or server. That was the common application we used. But I can add security to it. FTP over or with SSL or TLS again. So now we have FTP secured. Okay, and there's even a secure FTP as well, secure FTP protocol as well. And what it's going to do is add encryption on top to make that more secure. And that's for transferring a file from computer to computer. Remote access. A lot of times we want to remotely connect into something to help either manage it or potentially repair it. And those things could be at a different site. Example, think about Hack. You have Harrisburg, Lancaster, Lebanon, York, Gettysburg. I almost missed Gettysburg. I apologize. If I'm in Harrisburg and there's a problem with the computer in Lancaster, I might not need to drive there if I use a remote access protocol to get to that device, whether it be a workstation server or one of my networking devices. So I can use a remote access protocol to potentially connect to it and see if there's a problem or even repair it. Old school would be Telnet, allowing me to connect into something through command line. The problem with Telnet was it was not encrypted. As we do some labs later this semester, I'll even show you that Telnet is not encrypted. So most modern systems use SSH, Secure Shell. This does the same thing, allows me to connect remotely to switch, router, etc. to work on it. I connect via command line to put some commands in and fix something. This now adds encryption. So I'm still sending data back and forth, but it's encrypted, so it's going to be harder to compromise. I can also use remote applications like Remote Desktop or VNC, those sorts of things, to remotely connect to a device. Now, I might use a client up here in Harrisburg to connect to a server in Lancaster and maybe add a user, maybe take a user out, maybe help change the password on a user because they got locked out. And I could use things like Remote Desktop to do that. Now, again, some of these have their own security problems because things may or may not be encrypted, or they open up a port that could potentially be compromised. So, again, anytime you work with these, you're thinking, kind of bigger picture on, is there a vulnerability here? But that would allow me to remotely connect to something as if I was sitting there, and I wouldn't have to, drive to Lancaster to fix the computer. I might be able to fix it this way. That's your remote access. That is all some of your client server applications, if you will. We'll revisit some of these as the semester goes, but this is kind of, let me reverse here just a little bit. I'm going to go back to this slide. It's giving you an idea what some of these are about. That's giving you an idea what some of these protocols listed up here are all about. All right, the next thing they mention is like LAN, MAN, WAN kind of thing. Well, let's take a look. LAN, MAN, WAN are a way to classify the size of a network, if you will. A LAN is a local area network, so it's confined to a relatively small space, room, floor, maybe my house, or a small building. And it's all those devices that are managed by that network, if you will. And it might be a single switch and a single router like you have in your house. That might be all it is. But that is my local network that I'm using for maybe sharing the printer, sharing the internet connection. That would be a LAN. A MAN is going to be a little bit larger, metropolitan area network. This would be something maybe citywide. And I like using Harrisburg example because that is the capital of the state. So a lot of the state government buildings are in Harrisburg. So connecting those state government buildings together with a network would be a metropolitan area network. That'd be a good example of. And they might be using fiber optic connections between those buildings. They might even be using wireless, microwave, wireless connections between the buildings to create this metropolitan area network, so that I can communicate from the Department of Agriculture to the Department of Transportation. I can communicate between those. Meanwhile, a wide area network is just that. I'm connecting a greater distance. I might be connecting city to city. I might be connecting the Harrisburg office of our company to the Philadelphia office of our company. I might be connecting the Portland, Maine office of our company to the Eindhoven in the Netherlands office. That's the company my brother works for. He works in Portland. Their company is based over in Eindhoven in the Netherlands. So I'm using his as an example. So now I'm connecting together offices maybe in different cities, maybe even different continents, if you will. So now I'm using lines that I'm renting from some provider to connect those together, and I'm going great distances now. That's what they're showing you here. It could be a fiber link, it could be 100-mile fiber link, it could be a 1,000-mile fiber link, as an example. They also mention a personal area network. Some of us have these for things that we're Bluetoothing from our phone to our headphones or activity monitor, those sorts of things. That'd be a personal area network, usually a very small space. In many cases, kind of like wire replacement, getting rid of the cable between my laptop and my phone, or my laptop on my headphones, that kind of thing. That'd be your personal area network. And there's even a body area network that they mention. This is really now looking at the whole phone to my activity monitor, to my watch, that sort of thing. Maybe even to my bike, if I have sensors on my bike, that sort of thing. And then they also mention storage area network. This is actually a specialized network that here would be our regular network to some servers. Now the servers connect on a high speed, high bandwidth connection to massive storage servers. And these might be their own technology, if you will. And sometimes they are, I don't want to say proprietary, but sometimes they are proprietary high bandwidth connections between this server and these storage servers. That'd be a storage area network. That's the kind of thing you'd find at a large hospital when they're storing all the medical records and scans and imaging and MRIs and those sorts of things. I might have a storage area network for all of that. And then we also have our wireless local area network, wireless LAN. So using our wireless part of our network to connect our devices together. Okay, so when we start talking LAN, MAN, WAN, we're start talking kind of like sizes and areas and kind of what we're using to connect together. When we come back, we'll start talking specific topologies.